Hello friends, myself Pratibha Raundal, Department of Chemistry of KAANMS, ACS College, Satana. Today I am going to discuss about the introduction of free radicals. Free radicals, in this video we see the generation of free radicals, stability of free radicals and the reactivity of free radicals. Free radicals is defined as the species that contain the one or more unpaired electrons. Free radicals are generally less stable and react in a fraction of seconds with another species. Formation of free radicals. There are general three methods for the formation of free radical. First is the compounds that have an intrinsically weak bonds such as dialkyl peroxide. Compounds that on fragmentation form strongly bonded products such as the AIBN, which releases nitrogen gas. Photochemical generation light can bring the fragmentation of compound if the wavelength of the light is correspond both to an energy greater than that of the bond to be cleaved and to an electronic excitation of the molecule concerned. This procedure is suitable for the formation of alkoxy radicals from alkyl nitride or hypochlorites. In redox reaction, covalent bond may be broken by the electron transfer process either by accepting the electron from the donor atom or donating the electron to an acceptor. Examples of thermal reaction. In this reaction, thermal energy or heat is used to complete the reaction. When we take the reactant and we give the heat or thermal energy, after that the bond between the oxygen it get opened and there is a formation of free radical. In free radical, that free radical contains the single radical. One bond is formed by two radicals. When we break the bond, at that time there is a formation of free radicals. In addition reaction, the free radical undergo the addition to the carbon-carbon double bonds. The reaction is generally selective. For example, here the CH2 double bond CHX takes place exclusively at the methyl group irrespective of the nature of halogen. Then next is the combination reaction and the disproportionate reaction. When we generate the two radicals and that two radicals are added to each other, at that time there is a formation of molecule. In this, there are two free radicals on combined by the dimerization reaction or the disproportionation reaction. Here two Br free radicals are there. Here the dimerization takes place, that means there is a formation of Br2. When we take the 2-methyl radical, at that time there is a formation of CH3CH3. This is the example of combination reaction. This is the rearrangement. Here the free radicals are known to arrange in a certain circumference. For the example, the addition of free radicals leads to rearrangement due to the relief of strain in the cyclic system. Here this rearrangement is taking place in presence of CCl3. Again here bond get open, there is a formation of radicals. Again that reaction is completed in presence of CCl4, there is a formation of product. Then the characteristics of free radical. The free radical processes is starting first in the initiation step, then propagation step, then the termination step, and in that the substitution in saturated carbon atoms. Here energy, the radical catalyzed chlorination bromination can be performed both in the gas phase and the liquid phase. The energetic comparison of chlorination, bromination and iodination of methane follows here. Chlorine Cl radical is there. In presence of methane, there is a formation of HCl, and again there is a generation of new radical. That new radical is again added to the Cl2. Again there is a formation of CH3Cl. Again there is a generation of next Cl radical. That means that reaction is going on. Here the applications of free radical. Radical catalyzed chlorination bromination of alkene takes place readily both in the gas phase as well as the liquid phase. Here the reaction is starting from the initiator, then propagation steps are there. When we take the reactant in presence of SO2Cl2 and the peroxide, by using that peroxide it is the reagent for the free radicals. That means there is a generation of radicals by using the peroxide. That bond get cleave, there is a formation of here product. Treatment of aqueous solution of silver oxide with the carboxylic acid gives the silver salt of carboxylic acid, which reacts with Br2 to give the bromo compound with the elimination of CO2. This is the Hunsdiker reaction. In Hunsdiker reaction, the treatment of aqueous solution of silver oxide with the carboxylic acid gives the silver salt of carboxylic acid, which reacts with the Br2 to give the bromo compound with the elimination of CO2. That means here in this reaction the CO2 is eliminated. That reaction is performed in presence of Ag2O and Br2. That means there is a formation of bromo compound. This is the mechanism of Hunsdiker reaction. Thank you.